Thank you for inviting us. Thank you everybody here to meet us and to listen our story. Then I'm Valerie and I'm the CEO of Nodeum. Today so I will present a couple of things. I will present where we come from, our company's, let's say, stories and where we go. And I will as well go into detail about the products details and as well some of our use case. Then behind Nodeum there is a long history, and the long history started in 1997. I will be short, but I made the acquisition of the company in 2012 behind. That we have a companies behind Nodeum. And I made the acquisition in 2012. And before that, we had more than 15 years of history. And the companies originally came from Memorex Telex, very old dark age. But what's important by this is that we get some IPs from this time. And we have a know-how as well in the company in terms of IPs and software development, and especially about tapes. You will understand why afterwards. Yeah. And the stories and the story of Nodeum started in 2015, and we are now more than 8 years after, and I'm very happy to explain what we did during this time. Then basically, when I made the acquisition of these companies, I wanted to transform the market and putting on the market new products and new technologies. And I started from a papers and a blank ideas, and with papers, ideas, and say, okay, what can we do? Basically, we were starting the problem of the unstructured data deluge. Data is growing. Everybody speak about that. Everybody is aware of that. But okay, and what else? Data is growing. I would say people are suffering to manage that. What can we do? I do believe that here in this panel, nobody will say, oh, no, it doesn't exist. Then, starting from a vision, we spend a lot of time with my team to listen, customers and users, market. And the market in storage are based on the traditional, let's say, ecosystems, storage vendors. So vendors are about, let's say, block, about NAS. Everybody have seen, let's say, the growth of NAS vendor, Isilon, Cumulo. All of these big players are coming on the market from, let's say, from 10, 15 years now. And we wanted to start to transform these ecosystems, and you will learn how we did it. That is, let's say, design and build around NAS, block, tapes, cloud, object, storage. That's basically traditional storage vendors. And we wanted to accelerate the relationship across all of this storage, because we understood that from the customer's perspective that new demands are emerging. Customers have new demands. And these new demands cannot, let's say, fit into, let's say, these traditional storage vendor portfolios. We wanted to serve new business model. We will explain the business model in our use case on how we made these transformations. And one of them is to eradicate the time to spend in searching after the data. People are losing time to search after data across a multitude number of storage silos. And as well, we understood that in traditional customers, they have plenty of unstructured data. They are stored across a multitude number of storage silos. They cannot find it, but they cannot use it. And we understand today, 2023, that the gold mine, like we say, the gold mine is really where the value of the data are not on the primary storage, but mostly on the secondary storage. Everything which is produced today shouldn't be, let's say, handled and used day one. They will use later on. But to use it later on, we need to place it somewhere. We need to be able to find it back, and we need to be able to use it. Then I said, okay, We have perhaps an idea there. We have some things to do. We will design something. Unstructured data grows. And this is clear for everybody here. Second point in the situation is the hybrid storage model. We came from a model where everybody store everything on-prem to a model where everybody wanted to go to the cloud, and now back to the middle, with customers who want to store some data on-prem, some data on the cloud. Then we are completely on an hybrid model, with content moving back and forth from the on-prem to the cloud, to the cloud, to the on-prem. Hybrid storage is not a myth, it's a reality. And we have here identified a couple of use cases where we want to fit in. Edge computing. Edge computing is about end users who are generating content in autonomous vehicle on the camera side. We do have as well customers doing media. Then they produce a lot of content close to the camera. We do have use case of customers having, let's say, as well, generating content from MRI, do scanning. And the content are close to the scanner, basically. Burst compute, the bursting. What means bursting? Bursting is a capability to scale and to get an elasticity. Most of organizations have the infrastructure to organize, let's say, the throughput of their calculation based, let's say, on limited resources. But when they have spike of requirement, let's say they have new business, they have a new project, they need to get the elasticity to be able to calculate quicker. Let's pick up the example of customers doing animated movie, for example. They have a new project, they need to have a rendering farm to calculate the picture, the image, and so on. But this is very, let's say, an important project. They do not have the money to invest for 6 months into a new farm of rendering. They will rent a rendering somewhere. That the content has to move back and forth from the on-prem to the rendering farm facilities, and vice versa, and get it back the result. Is the burst computing. Bursting storage as well. I do not have space, but I need to have space during 6 months. Yeah, I will rent somewhere a space, storage space, and I need to place my content there during 6 months, 12 months, and get it back afterward. Remote worker, yeah, with the pandemic, everybody understood the problem and the challenge and the benefits of the remote workers. And archival storage as well is the last one. It's the last opportunity we have seen that content, like I mentioned, are generated so fast. We have to store it, place it during a couple of years, time 10 years, 20 years, and being able to recover it and use it. This is the situation. Then basically, most of organizations are coming, let's say, from a situation where they have a single storage there. They are completely comfortable to manage it. They are feeling well to a situation like this, where they have to deal with NAS, they have to deal with cloud, they have to deal with object storage, they have to deal with a complete, let's say, variety of different storage. They say, wow, what can I do with that now? I'm not so feeling comfortable now. And this is the situation where we like to be. To help the people on the right, feeling like on the left, but having, let's say, this type of requirement. Then we can see the on-premise storage market with the traditional vendors. I put it a couple of names. There are a lot of others as well. We do have on the right others as well on the cloud side. We have the public cloud vendors, the most important one, and I put it as well some of the vendors which are on the left who wants to move to the right as well and selling their services on the right. And today, 2023 now, the market recognizes that we need services on the middle. We need new services that never exist before. And these services is about the movement. It's about moving content across the left, the right, left and left, right and right. It's about the life cycle. Can we control and monitor the life cycle of a data across the years? Across its age, basically. It's about archiving. It's about protecting this content. It's about as well searching this content. And today Nodeum is there, on the middle. We are there to facilitate end users and organizations to do this stuff. And during this presentation, I will explain how we do it, how the product looks like, and I will explain as well our use case. Any questions? Are you surprised?
Whom do you see as your main competitors? I mean, there's a lot of products out there which is named Data Mover,
Yeah.
and these are your competitors.
We have, let's say, I can have three names.
Yes.
Comprise is one of them. Strong Link, Strong Box is another one. We can say Tempo, Myriad can be another one. There are others on the market.
Sorry?
There are others as
Yes.
well, but if I need to put three names,
Yes.
it's the three I have in mind. Any other questions? Then today I will not speak about IOPS, I will not speak about throughput, I will not speak about a lot of things like this. I will explain how we transform the end users, organizations, to cope with such kind of things. We will go in the product detail, and I will spend the time as well to explain the use case. Then today, the data management is not anymore a myth, but it's a reality. And I'm smiling because I read the news and read the storage vendors, traditional storage vendors speaking about data management, but they are not people doing data management. They are people that are designing storage appliances. They store content. They do not manage data. For us, and it's what the market says, the data management is the services I showed you. It's about searching. It's about moving. It's about protecting, archiving. It's why we built Nodeum. We serve 4 markets today. And these are the traditional markets where we can see, let's say, the data growth, unstructured data growth. It's about research, genomic, digital pathology. It's about geospatial, Earth observations. It's about university. It's about media, broadcast, post-productions. If I go into detail, our top 5 today, in terms of market, is first HPC and supercomputing. We see from more than now 12 months a big hype in supercomputing. We have a very great penetration in this market. We have a great feedback from the end users. They love the product. Afterwards, we do have a traditional market, is the media, post-productions, but broadcasters. We do have number 3, the life science. It's about MRI, scanning. It's about DNA sequencing. It's about blood analysis. The number 4 is the Earth observations. Earth observation is again question of image coming from plane that's doing pictures of the Earth. It's about satellite doing Earth observations. And we do have universities, and universities is mostly as well research. We are more focused on universities that are doing research. Then today our missions in regards to this market is to help them to simplify. We are there to simplify their storage organization. And we want to simplify the process to archive, protect, move the content. It's about scalability. That's great to be, let's say, in a market where the data is growing like never. It's beautiful. You talk with the customers, it's always more than what expected about the growth. It's always, you will talk about, I plan to do 1 petabyte next year. Okay, you talk to him next year, the years after, it's 2 petabytes, it's not 1. Oh, excellent. Oh, wow, yeah, that's fine. That's excellent, it's good news, market is growing, it's beautiful for us, but the scalability is key. You are not dealing petabyte like terabyte. You are not dealing exabyte like petabyte. The scalability is key. The demand of the end users are, I need throughput to move as fast as possible the content. Why? Because my business determines that. My business requirements are so strong that I need to move fast. And this in a scenarios that we have the content are dispersed across different storage. Could be a tape, could be a cloud, could be an object storage, could be a file-based storage. Simplification, scalability, and unification. Unify the process, unify the operation for an end users to be able to move back and forth the content. Moving data between a file system is easy. Pick up your Windows Explorer, you see your file system, you see folders, subfolders, files. That's nice, it's easy. Pick up an object storage. It's different. It doesn't work like files. You have paths, you have objects, you have buckets, you have keys to connect to. Well, it's not the same. We can go about tapes. It's another story. Tapes. Ooh. Complex, difficult. I have a lot of headache. It's dead. Yeah, it's dead. No, it's not dead. Nothing is dead for us. But being something completely unified and helping from an end user's perspective, because we want to address this product to not specially to IT, but to the market, the people who have the money. And the people who have the money are the people doing the research, are the people that are using the supercomputers, are the people who are doing the production of movies. These are the people who have the money. And we want to help these people to understand that they can use the software to handle and to solve their challenge. Then the unification and the capability to automate and simplify the operation is key in our mission, and the product is designed for doing that. We are there to help the end users to, I will do a couple of clicks, but the idea is to be able to move back and forth content from an object storage, a public cloud, a tape, a NAS, like doing a drag and drop. And here I will go into the detail now on the product side. We'll go perhaps a little bit, let's say, technical. If you have any questions, raise the hand. I will answer. You can ask questions, I'm pleased for that. I will go more into detail in the heart of the product and what are the key features behind. What are the key features? Then around this story, it's about basically a powerful data mover. We want to lead the market of the data management. We want to lead the market of the movement. Then point 1, it's super performant. Point 2, the data movers is designed to calculate and verify all the checksums integrity. Because moving file is easy. Again, a lot of people can say, I can move content. But moving 1, 2, 3, 4, 10 files is fine. Moving millions of files is another story. Because the end users who wants to move the millions and millions and millions and billions of files wants to have something easy to move, as I mentioned, but as well make sure about the checksums calculations, the integrity, and as well the verification and the monitoring behind. Pick up, we do have customers doing brain analysis. Okay, they do a brain analysis for a patient. If they lose 10% on 1% or 2% of the content, it's a problem. They need to call back the patient to go back in the machines and rescan and redo the calculation and start again. It's got a lot of money. TV show, you produce a movie, you do a shooting. If you lose 1% of the content, it's a problem. Now this is the key. It's a powerful data mover. It's fast, it's high performance, but as well, pillar 2, pillar 3, we verify and control everything. And this is a key value for most of our customers. They love Nodeum because it's fast, but as well, they are feeling well. They are feeling well using the product because they are feeling comfortable to make sure that everything is under control. That it's about technology, but it's also about interface. Then Nodeum is one software to move and migrate unstructured data. Okay? And I will cover a couple of key features now. And in the key features, I will go through all of these topics mostly. Yeah. It's how we can organize data movement across different repositories. Different repositories, it can be an object storage, like I mentioned, a file, a POSIX file system, a GPFS, a Lustre, whatever type of technologies. It's as well the capability for an end user to access the storage and the services to handle the movement like they want. Point 3, this is a key features we have launched early this year, is to be able to integrate Nodeum as a data mover services into workload managers for accelerating the efficiencies of HPC supercomputing systems. I will go into details on what we did for handling that. It's very key and important. Providing as well public API, SDK, everything around the interface that can help end users workload to connect to the services, and as well our interface. Okay? Then here we will cover, let's say, all of these aspects for a technical perspective. Then it's a complete new architecture, modern, microservice-oriented, new design, and I'm very happy to present that. And this is really the response, like I mentioned. Starting, we wanted to be ready for the edge computing, the supercomputing, and moving the content. Because moving the content, this is really the introduction of the scalability. I will start to explain the scalability layers afterwards. People have too much data. It's too much. Just imagine here the number of data that you will generate during this day. It's you. And Fred will do a repository, and I will be surprised to see the capacity of the repository after one day. Just collecting all the videos, the image, the sound, it will be amazing. It's too much data. Too many files as well. Because yes, we love customers saying, oh yeah, I have files of around one gigabyte per file. Oh, that's nice. But we do have customers saying, oh yeah, I have some files about kilobytes. This is another story because we are really going to the billion magnitude of number of files to be managed. It's another challenge. And like I mentioned, most of customers, they do not care, they want speed. They want speed even they have a lot of many files and they have a lot of data. Then the new architecture is really designed for that. And all the components are designed for handling that. That, like I mentioned here, just a diagram. Everything is public. You can do picture. On the top here, you see, let's say, the workload. We can see HPC, some people operators, some devices, cameras. For example, we see an MRI scanner, some Hertz observation, let's say, systems for satellite. And we can see here that these end users and systems are storing mainly on the primary storage of content, which are mostly, depending of the, let's say, of the industry, can be a GPFS, a Lustre, can be a BGFS, can be such kind of things for HPC, for example. Others are dealing with Dahlia Xylon, StoreNext, are dealing with what can we find, a Cumulo, and so on. Okay, depending, I would say, a little bit about their what they have as workload and what they like. Then we have the primary storage there. We have here on the bottom the secondary storage, which can be the same one basically, but can be others. And we can introduce here as well that we have connectors for Swift, S3, and we can handle as well here the different protocols for object storage on the back as well. On the left here, we that the new architecture is designed for plugins oriented, and it's very easy to define and design new plugins that can cope with some specific customers' demand. We do have a nice plugins, for example, for scanning very fast and managing, let's say, the workload of Isilon clusters. Basically, this plugins is very powerful because it can help our customers running an Isilon, for example, to do a performance analysis of the nodes, on the clusters, and doing the elections of the best candidates for handling the most of the throughput. Then we can scale the performance, for example, in running the data mover services here with an Isilon in using this plugin. We do have as well plugins to do, let's say, the mapping of the end users. You will understand in our use case, we have scenarios where we have on the left users using, let's say, a POSIX file system, then basically it's a username password. And we have on the right people as well using an object storage with keys, tokens. And we need to be able to do the mapping from an end user's perspective to handle the movement with his identity, which is a user password on the POSIX file system, and which is, let's say, a pair of keys on the object storage. Okay. And we have the capability here as well to connect to IDP providers like OpenID, SAML, OAuth, and so on, for handling such kind of things in terms of, let's say, authentication. And on the middle, we can see here, the data mover services, Nodeum, that we do have, let's say, schedulers or monitoring services that monitor the complete service. We have the plugins for handling authentication authorizations. And we have the most important services, which are the mover services. We are doing the operation of moving the content. And here on the top, we can find here the web services. Everything is web services based. Then all the interface from an end user's perspective are using the web services. And from the web services, we can expose the SDK, we can expose an HTML5 console, and we can as well expose an ND client, which is a bash client. We will go into detail about that later on. Okay, any questions on this?
All clear?
All clear? Good. Let's go to the next. That's the benefit of an automated system and data services like it is to provide these four, let's say, pillars. That's 4 features we provide in the system for helping end users to manage the movement. It's policy driven. We have a very great data selection features. We provide as well schedulers and filtering. These are the 4, let's say, key features. We have others that we'll describe, but these 4 are very key for doing the automation. The policy driven is about, let's say, to define the policy of what the end user wants to do. He wants to copy, he wants to move the content, and organize, let's say, the workflow he wants to achieve. Data selections. Some of our competitors, they say, yeah, pick up storage A and you go to storage B. Okay, what else? You have to pick up storage A, you go to storage B. It's not the case here. You can do that. But you can as well use the systems to be so granular to really select the contents you want. You can define an unlimited number of policies like this with a different unlimited number of, let's say, data selection. Then you can say for the same storage, you can have 10 or 100 policies, for example. Depending on the data source you want and the policy that you want to define. You can say, for example, I will do let's say a workflow for handling the movement of this subset of content. I will do another type of workflow for handling another subset, for example. The schedulers will organize and optimize the movement for a time basis. That you can use the scheduler to say, okay, I want to move my content and starting during the night, or I want to get it now at noon, or I want to do it on automatic, for example. And filtering is the last one. We will go into detail. Is the capability to filter the content. Okay. From there, I promised you about scalability. We designed a system which is fully parallel. The system is designed for providing parallelization at each layers, and especially on the mover side. The system is very designed for answering the demand, if you remember a couple of slides before, to handle a lot of files, a lot of content. Then we can scale the mover services horizontally and vertically. Then, what does it mean? You can have an unlimited number of servers that will run the services. You want to get more throughput, you add servers. You can as well scale the number of services running on one server. For example, you have very small servers, you have one services, you have very huge servers in terms of resources, you can have multiple services running as well. And when the scheduler will organize and say, okay, now we need to move this billion number of files, the system will do the election of the number of mover he needs, depending on the criteria defined in the policies, and he will elect the number of services available to execute the movement at full speed. Then an end user running the system can scale in adding the number of movers and also in having some specific resources attached to the mover to as well scale vertically.
Meaning the services are the movers.
Sorry?
Once you're talking about services and once you're talking about movers, but the movers are the services.
Yes. Yeah, okay. Right. The mover are the main services of the system. Yeah.
Mm-hmm. So you could, let's say, in your rule specify optimum would be 5 data movers, but if you only have 4 in that moment, it will only take 4 and go. It would not ask for the 5th one, but it would go.
Exactly. We designed it for being, let's say, scalable, but as well, the agility in terms of handling the infrastructures is so easy that you can add new mover, you can remove movers, and the system will cope with that.
And the mover, what is the physical base for the mover? Is it a virtual machine or is it?
Whatever. It's virtual machines, it's physical servers, it can be Dockers.
Can it be containers?
Yeah.
Okay. Yeah. So if you put a mover on a physical machine, then it will probably be quicker than if you put it on a virtual machine. Yeah. So you would have low performance movers, several of them on one server, or you would have one very broadband and quick mover on one big machine.
Exactly.
And you could combine small and big ones to have some granularity. For example.
Yeah, definitely. Perfectly right. Okay. Yeah. And you can add new.
So you would have farms of movers.
It's farms of movers. Yeah.
Would they be distributed locally?
Distributed, completely distributed.
Or you could also concentrate them in one place. If you have a source, a big source of data, you could put the movers there and have the goals where to put it. Yeah. You would have in other places.
Exactly, you can have.
For example, if I want to have a multi-cloud backup or something, you would put all the data movers in the central location, and then you would probably move the data wherever you want to distribute it.
Perfectly, you're right.
Okay.
You can do such kind of implementation, and as well in terms of security as well. For example, you can have your mover close to the storages and have all the other services, let's say, far away.
Would you put it more to the source of the data or primary source, or would you put it?
It really depends on
the architecture.
Use case. Okay. And the customers is completely autonomous to deploy the system like he wants. Of course, we are available to help him with the system, but he has everything he needs to deploy, let's say, the global services following his requirements. Of course, I'm talking here about scalability, but as well in terms, let's say, of failovers as well. If you have one mover that go down, the system record what content has been moved by the nodes, by the systems. And if you are running, for example, I'm moving 1 million files, and I only move 800 files, and we still have 200 remaining, you shut down the servers or the service which are handling this movement. The system will recognize that only 800,000 has been moved, and we have 200,000 remaining, and the remaining nodes will restart the service and continue the movement. Mm-hmm. And it's scalable, but as well in terms of failover, it's very robust. Any other questions on this? Then I mentioned the question of moving throughput, but in terms of control as well. Each data movement that has been executed is monitored on a file level basis. Then here I believe you see the screen here on the right. Per movement, you see the list of files that have been moved. You see the status of the movement of each file. It's, let's say, displayed in the different, let's say, interface we provide. This is the, let's say, screenshot from the HTML file. Then I see the file names, which came from, let's say, an NFS repository. Yeah. No problem. You see the size, you see the time as well when the file has been copied. Then you have a clear picture, basically, of what's happening in real time. You execute your movement, it takes, let's say, a couple of hours. You see in real time where you are on a file level basis. The system will start by doing the collections of all the files that have to be moved, and you will see in real time the status of the movement of each file. Because it's not only a question of copying, about the throughput of the copy, it's a question as well to discover the content. And this is another thing which we are very proud to say that we have a unique technology in this regard, is about, let's say, the discovery. Most of data mover has the problems, let's say, to wait during, let's say, you run a movement, you have to sit down, wait a couple of hours that the discovery is done. And after it starts to move. And time to time, you can imagine that the discovery can be very long. You need to be patient. In our technology, it's not like this. In our technology, we have, in the data mover services, different, let's say, microservices in the back. And one of them will do, let's say, the discovery during the time when the other service will move. Then for end users, he will never get the perceptions to lose the time to wait for the discovery. He will always have the impression that the system works and move and move and move. And during the movement of the file, he will continue to discover. And this panel I showed you here are very great and nice for helping you to determine and to see, okay, I'm sure, are we sure that the discovery is finished or not? And the system will say, no, it's not. I'm still discovering files. But during the discovery phase, the end users will see the file started to be copied or moved. And this is real time. End users can control as well. He can do everything he wants about the movement that are running. He can pause it, he can stop it, he can restart it. And say, okay, I want to pause now. I can pause it, and 2 hours later, he can restart it, and the system will restart exactly at the time, well, at the stage where it has been paused. He can stop as well directly on movement. And if he pause, he stop, he restart, again, in terms of traceability, he will always keep a visibility, let's say, of the file that have been processed, have been calculated, have been discovered, have been copied, have been moved. And if there is a problem somewhere, he will see it. He will see, okay, there is a problem with these files.
When you stop movement during a very big file, and you have to restart it, will it start at the beginning of the file or where it just stopped?
We restart at the beginning.
Okay.
We always keep, let's say, we took always the decision to say we prefer to lose a little bit of time, but make sure that the file is fine. Yeah. Mm-hmm. We never trust some things where we manage that. It's like when we have to store content on tapes. We never store, we store always a file on the tape. We never span across two tapes one file.
Okay,
yeah. Never. We prefer to say, okay, we lose space. It's more cheap than in the past, but we have the file. Filtering modules. It's a key element of a data mover for our perspective. It will help our customers and end users to determine exactly the content that has to be moved. We have, let's say, a basic modules for filtering where it's easy. You can select, I want to filter only these extensions or files, for example. I want to filter on the path and I determine the path, or the file names as well, I can use it, or the date. So I want to filter based on the last access date, for example. Everything that has been accessed during, let's say, the last 3 weeks, I want to handle it. But you can as well create more complex filters in using a scripting. That we are really, the basic is no code and the advanced is code. And you can code your filters. And this is very powerful because at one stage, it's about conditioning. It's about, and you say, okay, I want this extension and this one, or this one and this one. Then with the let's say the advanced filtering, people can play with the conditioning on the way they want.
Is this your own filtering language? Or some common?
No, yeah, it's common language, yeah.
Okay.
Yeah, it's common language. This one, if I do remember, should be a Lua. Language. Yeah.
Could I create a complex rule also at the no-code level, or do I have to touch the code?
No, you can use a complex one. The key differentiators is the conditioning. Mm-hmm. With no code, you have one type of conditions. You cannot, let's say, play with the condition.
Okay.
Yeah. It's when you want to have all the different, let's say, filters with different conditions across all of them. You have to go to the no code. But you can prepare the basic all your filters. Mm-hmm. Go in the advanced, it will, let's say, provide the code related to the GUI, mm-hmm. and then after you can do adaptation.
Okay.
Yeah, it's easy, like it is. Yeah. Any other questions on this? Priority management. We review completely our mechanism of priority in these new versions and say, okay, priority is important. I will get back my plans this evening. Everybody wants to be in the fast lane. Everybody wants to be priority one. It's like it is. When we speak to end users, it's one of the fear. Because when you say, oh, there is a priority mechanism behind, oh, that's fine. I want to be always the priority number one. I want always priority. And traditional systems say, okay, you have a priority system, and okay, we always prioritize the movement which is in the top priority, and we go down. That's okay, but at the end of the day, there are a lot of people that are doing those things and will never get the workflow executed. Never. Then we implemented a fairness priority management now, saying that let's say I will simplify the explanation, but this drawing explains it. Then I have here a couple of priority lanes. I have the P1, the P2, and the Pn. And basically, all of this one in gray will be on the top priority. Then if I run, let's say, a traditional system, it will consume completely, let's say, the queue. And all the throughput, all the resources will be consumed for moving the content. And the P2 will never be executed, and the Pn even more, never. We have implemented another mechanism saying, okay, it's fairness. It's, okay, we run P1 and we move P1. But time to time, we have a look on what happens on P2, P3, Pn. Say, okay, I see there's a couple of things to be done. And then we decide, per algorithms, we define our algorithms to say, okay, time to time, we decide that we will allocate some resources for P2. And afterwards, we say, okay, now it's time that Pn will be executed. Then again, from an end user's perspective, even if they are in the lower priority, they always get a chance to be executed. Then again, end user's perceptions, simplification, we want unification, we want to say, okay, yeah, I'm not in the top priority, but I have the service for me. Questions on this? back to this question of the workload managers integration, that we are very proud of this integration. It's very cool and nice for the end users. And this is mostly dedicated for people doing research, HPC, calculation. It's about workload manager. Workload managers basically are the software that will handle the resources of supercomputers. Supercomputer, is just a big amount of CPU, a big amount of memory. That's it. Okay? I simplify the question. Okay? And a big amount of money as well. But yeah, it's a question of resources. And the end users who wants to get their calculation, they will have to submit the calculations they want to the supercomputers. And the supercomputers, depending of the queue, depending of the usage, they say, okay, now you will get a slot for doing your calculation, let's say in the next 4 or 5 hours, and you will get some resources to do it. And one of the famous softwares that handles such kind of thing is Slurm. Slurm is this one, is one of the biggest, it's perhaps the biggest. I think that 50% of the top 10 or the top 50 biggest HPC are running Slurm in the world. That Slurm is the software that handle that. And the question now, we say, okay, we work with our customers on this and say, okay, it's great, we do have Slurm, but again now about Slurm, Slurm is using here some compute nodes, and the question is, I need to get my content on my compute nodes before my calculation will start. And remember the story when we have in scenarios with end users having plenty of storage, it's fine to get, let's say, the Slurm handling, let's say, the capability to say, I will execute the movement at this time, but I need my content available before running. Then we made an integration of our data mover services of Nodeum inside Slurm for automating, let's say, the movement before executing a calculation and after. That now, when the end users running Slurm, they can use our services to say, okay, I will prepare my job of calculations, then I will say, explain what I have to do, and before I can say, now I will ask Slurm to move the content I need close to my compute node. Then when I will run my calculation, the data will be moved by Nodeum before, and when I finished the calculation now, he will get back the result and pushing back the content somewhere. Then now they can have the movement service completely integrated in their Slurm. And this is fantastic for the end users because they do not have to take care of that. They can handle this type of, let's say, of automation in the background. It's automatic for them and it's transparent, and they can monitor as well. Any questions on this?
Guys, why are there no questions? What I'm wondering is, Valerie's answers are very, very clear. You're not following him, or you already know everything. And I'd just like to get an idea so that maybe Valerie can tweak things.
For me, it's clear. For me, it's clear what he's saying. So he's a very good explainer.
Oh,
good.
It wasn't I wasn't criticizing. I just was offering values in the questions and.
I was the questions.
Maybe one
Yes.
question.
Don't hesitate.
That's all about scientific and high performance computing, supercomputing. Do you also have customers that are using it in a standard enterprise data center, for example, for big storage migrations from NAS to object storage? But that's not your traditional use case.
It can be, yes.
Okay.
But it's not so mainstream. It's more mainstream compared to this because here the requirement and the complexity of the movement is, let's say, it's more complex a little bit. But we have users that run the service to move back and forth more in an enterprise, let's say, model the system. Yeah. The integrity check. I have a look on my watch. Is done on multiple levels. Again, I explained this is really key when you do such kind of things to make sure that the integrity of the content you move are well performed. Then basically we have several layers, and like you mentioned that we always make sure that we never find a situation where we have only 50% of the file. It's 0 or 100. Always. 0, there is a problem. 100 is good. Okay, and we made the verification back and forth every time, and to avoid the, let's say, the corruption or the loss. Mounted file systems. The system is designed for handling NFS, SMB, like I mentioned, Swift, S3, and so on, but as well some mounted file system that we are completely compatible with an IBM Spectrum Scale, GPFS, Lusters, BGFS, StorNext as well, which are, let's say, file systems which are a little bit different, let's say, than others in terms of connection and protocols. And we have the capability to address, let's say, the connections to this. Then we have a very strong use case you will learn afterwards about moving content from a GPFS, from a Luster, for example. Then this is a very strong value add for vendors. We are, let's say, in an ecosystem with such kind of vendors. They can use the service as well in an ecosystem of IBM, of Quantums, for example, and others. The hook services, then if you remember, I spoke about the fact that an end user, we want to integrate to be close to the end users. They want that an end user will get the benefit of a data mover. Then we integrated as well the capabilities in the data mover service, which is the hook. And the hook is a capability to run code and script code at different stage of the movement. And basically, they can run a movement. They can run a code before moving, during the movement, and after the movement. That, for example, if they want to integrate, let's say, a business workflows after the movement, basically the system will move the files that has to be moved, and when it's done, they can execute a code which is completely secure for running perspective, and the code will allow them, let's say, to provide some trigger, some event. They can, let's say, do some operation to, let's say, have, let's say, a cascade of event, a cascade of, let's say, of functionalities, and when the movement can be placed on the middle of a business application. Okay, talking about traditional, let's say, let's go to the media, for example, industry, the media. When they receive the content and on the post-production, for example, they have to do several stages. They have to verify the content, they verify the subtitling, the effect. They have to do a lot of things in operation, and the file have to be moved back and forth. Then they can handle the movement with Nodeum, for example, and they can integrate as a hook the different, let's say, operations that they have to execute around the movement. Okay, then they can have a one end-to-end again operation. Users management, we have several use cases now where we can handle, like I introduce it, we can handle, let's say, the authorization of an end user based on different, let's say, type of credential capabilities. We can support username, password. Then me as a user, I can connect with my username and my password to the service, and this username and this password will be used as well to access the different storage. But that's fine for a file system. But when we are talking about object, it's different. Then when we are going to the object storage, we can use keys, pair of keys. We can use as well tokens. Then we have such kind of same mechanism that you have when you want to connect, and you have on the web, for example, and you have the capability to select a Facebook account or to select a Gmail, a Google account, for example, to do the authentication to a services on internet. We will not use a Facebook account, of course, but we use the same mechanism of single sign-on, that the end users will use his email address, he will use some password to access the authentication services, and he will receive tokens. He will receive tokens for managing the access to the object storage, for example. And we can mix, thanks to our plugins, we can mix, for example, in the movement from a file system, a POSIX file system to an object storage, we can mix on the left traditional username, password, and on the right we can have tokens, for example. That from an end user's perspective, it just makes his, let's say, connections to the service he is authorized, he can access the file system, he can access the object storage with his profile. Now back to the interface, because it's one of the things from my perspective is very important. I have seen, I will not speak about my story of my Mac today, because bad experience today of Mac. But I love Mac for one thing, it's easy to use. Then I put a lot of effort, and for me it's very important to get interfaces which are very clear. Then the interface for us is the number one, because it's which is in the middle between the end user and the technology. Technology is beautiful, but you can have beautiful technologies and have very ugly and not usable interface. Then at the end of the day, you will never use it. Never. And even more today, because we have less and less time, everything has to be immediate. Then we put a lot of effort in the interface. Then we have a bash client. The bash client is a new thing. The bash client will help to run the client, let's say on a computer, so on a Mac, a Windows, a Linux, that everybody can deploy it and can start to execute movement. It will not execute movement with his computers, of course, but the client will connect to the service and will handle the operation of movement. Then basically, everybody with a computer can execute a movement with the client. It's very easy, it's bash, they can type command and start to handle, let's say, request of the data mover services to move the content. It's using web services and APIs in the back, and they can control and manage all the movement. In addition of this, we have the HTML5 console, which can do exactly the same operation, let's say at 90%. Okay, that the end users can run the operation of movement with a GUI interface HTML5. Can run on tablets, mobile, and so on. Okay. Back to the use case now. Any questions? Clear about the technology side?
As far as I remember, you integrated your own search engine into the solution. You didn't mention that?
I didn't cover this in the news of but yes, we have a search engine, which is we use some open source component on this for doing the indexation, and we present the content on let's say on the search portal, and the search portal can provide, let's say, the capability to type some keywords, and you can type keywords and search after the content across a single namespace, basically, which handle, let's say, all the storages that are available. Then you can use the keywords, you can use some metrics, some metadata, you can use the storage, you can use the path, you can use basically everything, and in the back, the engine are very powerful to scale again and to be able to provide this search engine, which is part of the HTML GUI. This one. Yeah.
And did I get that right? You have one single namespace over all the files in the Nodeum universe.
The one which are the answer number one is the secondary, because it's where we believe there are the most of things to do, and then you can get you can find back the content, but you see as well the life cycle from when the file has been discovered, mostly on the primary, has been moved to secondary storage. You see the time, and you see the complete life cycle of all operation that has been done in terms of movement, archiving, protection as well, and you see some icons like this. I can do another, I can send you back some information about this.
Okay, excellent.
Yeah, I can do that. Any other questions on this? Okay, let's go this, and I will spend the time I need, because unfortunately my computer doesn't want to work, and for the demo it's more complicated. I will spend the time on the use case now. Then Phoenix Era is a European project. It's an infrastructure in Europe that help, let's say, research center and supercomputing agencies in Europe to collaborate. That is a federated infrastructures. Then mostly all of the research center in Europe can use it. Okay, and we get the chance, let's say, if I can say like this, but it's a great opportunity to place Nodeum as the main data movers in the Phoenix infrastructures. And the Phoenix infrastructures is available through, let's say, the 5 main supercomputing centers in Europe. The number one is in Germany, sorry for the pronunciation, in Jülich. and in Jülich, yeah. The second one, we do have Barcelona Supercomputing, the CEA in France, and we do have as well CSCS, which is in Switzerland, and Cineca in Italy. These are the top 5 supercomputing research centers where they use Nodeums. Then the objective in these infrastructures was to handle the movement between GPFS clusters or S3 GPFS and Lustre storages, and an object storage OpenStack Swift, and as well as S3. Okay, and they need a data mover service to handle the movement across all of these technologies. And this data mover has to be served for the end users doing their calculations on these computers. Okay.
So the data mover needs to be part of all those file systems, right?
Yeah, yeah, exactly.
So what is your experience? Will it work quite well because you have to install some driver software usually for Lustre, for GPFS, for Cumulo or whatever file system? And will they work together always?
Yeah. That's first. They can work together. If not, we can have a mover dedicated for one storage and also mover for the storage as well. This is completely, let's say, up to the organization to design the solution like it is. Yeah, we can have dedicated mover to get the content back and forth from a GPFS. We can have some nodes for handling the Lustre connection, for example, and then you can design the solution like it is. Yeah. And you can have mover which will handle only the movement to objects to OpenStack, for example, as well. Yeah, that's the idea behind. Then basically they do have the active data repositories and they have the archive data repositories. And for example, in Jülich, the active is GPFS and the archive are OpenStack. Okay, and then they can move back and forth the content from the different, let's say, technologies. University of Röstock is one of our key customers as well in Germany. They are handling the movement of the data coming from an S3 storage and going to the tape storage. One of the big achievements for them as well is the capability, let's say, to expand the 3-to-1 rule in archiving as well. Okay, 3-to-1 rule is very famous for backups, but they wanted to do the same for the archivings. The Graz Medical University is a university in Graz, okay, in Austria. I love this example and this use case because it's where you understand that doing technologies and in infrastructures like it is can be very, let's say, a game changer. And here the problems they got here is they had a high throughput MRI scanner. They scanned some slide for doing cancer research. Okay, then the objective for them is doing the extraction, doing the scanning of the image, and after to store it to a first layer flash storage, doing some metadata extractions to get, let's say, some pattern and just to identify a couple of things that can help them to determine if the patient is sick or not, and after store the content. But the problem they got is that when the scanner scans one slide per minute, that is a very big engine, the process behind was completely, let's say, manual and took 10 minutes per slide, and managing 1 minute manually took 10 minutes for them. Then you can directly imagine that the flash is completely overloaded, the scanner stopped, and at the end of the day, the patient cannot be treated. We came in the equations and demonstrate that in using Nodeum as a data mover in our automation system, in moving fast but integrated as well in their workflow, we reduce by less than 1 minute the process to move the content out of the flash. Then now they can run 24 hours per 7 the scanner, and they can help more patients. I will go fast. We do have as well some data services in the data centers for replicating content. We have a use case in the space industries as well for data acquisition from the satellite. We do have use case in the MPC, in the broadcasting, the post-production. I think that I have 3 minutes. I will stay on time. Then, yeah, we do have plenty of happy customers, especially in the Dash region. For us, Dash region is very key. It's a key market for us, this region. It's why we are pleased to be here today and to explain our technology, because the expansion is very important, and as well the use cases are present here in this region, and we are ready for helping the market. And some of the testimonial of one of our customers, they say, okay, it simplifies for them the data transfer. It simplifies. Demo, I will skip. The next event where we can meet us, we will be next week in IC in Hamburg, Supercomputing, and we will be as well at Huawei in Munich here next week as well to present our services to the Huawei Infrastructure Forum. Thank you so much for listening to me. Thank you so much. Thank you, Fred.
Thank you, everyone. Excellent session.